I am Dr. P. John Thomas, Assistant Professor in Microbiology, St. Joseph College of Arts and Science, Kadalur. Hereby I am representing self-learning tools to my students. And the subject is Principles of Microbiology. This first MSc Microbiology, first semester paper. Subject code PMB701S. And Unit 4, the topic is Classification of Virus. So first we can see about the general properties of virus. So what is virus means? Virus are obligate intracellular parasites. Their size ranges from 20 nanometer to 300 nanometer, and they are ultramicroscopic in nature and seen only under electron microscope. The genetic material can either be DNA or RNA, but never both, and viruses can replicate only inside a living cell. So classification of virus. So viruses can be classified based on the genetic material and based on Baltimore classification of virus. Baltimore scientist David Baltimore classified the viruses into 7 groups, and based on the morphology you can classify the virus, and based on the multiplication, based on the hosts you can classify the viruses. So based on genetic material, so the virus is made up of only 2 genetic material, either DNA or RNA. So you can call as the DNA group of viruses and RNA group of viruses. So DNA viruses, RNA viruses. So DNA viruses, we have some 6 families of DNA viruses. A family Poxviridae. All the pox viruses comes under the group. Here I given 2 examples. One is variola virus and molluscum contagiosum virus. So these are 2 important viruses which causes infection in human being. Variola virus causes smallpox and molluscum contagiosum causes swimming pool infection disease. The next one is herpes virus or herpes virus. So there are different types of herpes virus. Herpes virus 1, 2, 3, 4, 5 and 6 is there. And we have herpes virus 1, herpes virus 2, varicella zoster virus, cytomegalovirus, Epstein Barr viruses. And third family is adenoviridae, adenovirus, which causes eye infection and respiratory infections. Then fourth one is hepatitis virus, hepatitis B virus. We have 6 different types of hepatitis virus: hepatitis A, B, C, D and E. Among these, the only virus which has DNA as genetic material is hepatitis B. All other hepatitis virus has RNA as the genetic material. Then Papaviridis, we have 2 important viruses which cause infection in human being. One is human papilloma virus, HPV virus, often called papilloma virus, which causes genital infections, and JC virus, John Cunningham virus. Our next family is Parvoviridae, B19 virus. So these are the 6 different families of DNA virus. Totally we have only 6 families of DNA virus. Then next one is RNA viruses. So in RNA viruses, the first one is Orthomyxoviridae. We have influenza under this family. All the influenza virus, influenza A, B, C, D, E, and all the influenza subtypes will come under this group. H1N1 viruses will come under this group. The next one is Paramyxoviridae, and the best example is respiratory syncytial virus, measles virus, and mumps. Respiratory syncytial virus causes respiratory infection. Measles virus causes skin infection, and mumps is an infection of parotid gland and salivary gland. And Coronaviridae, the coronavirus, and rhabdovirus. Coronavirus causes respiratory infection. Next one is Rhabdoviridae, rabies, a mad dog bite, which causes infection in the nerves. Then Picornaviridae, we have enterovirus, rhinovirus, and hepatitis virus, hepatitis A virus. Then Calciviridae, we have normal virus, and Reoviridae, rotavirus, which causes infection in children, rotavirus diarrhea. Then family Retroviridae, HIV1 and HIV2 is the which causes AIDS, and HTLV virus, human T cell leukemia virus. Then Togaviridae, rubella virus and alpha virus, group A arbovirus. So group A, ARBO means here arthropod-bound virus. Then flaviviridae, example hepatitis C, flavivirus, group B arbovirus. Then Bunyaviridae, hantavirus, then California encephalitis virus, then Filoviridae, Ebola virus and Marburg virus, and Arenaviridae, lymphocytic choriomeningitis virus, Machko virus, Guinin virus, and Lassa virus. So that's all about DNA viruses and RNA viruses. Next we'll move on to based on morphology, based on their size and shape, we can classify the viruses. First one is ecosahedral symmetry. Ecosahedron has 12 vertices and 20 facets. Then enveloped virus. Most of the RNA viruses are ecosahedral symmetry. And next one is helical symmetry. And helical viruses, the first important virus to be discovered is tobacco mosaic virus. It's the best good example for helical symmetry. Then envelope helical symmetry, we have rabies virus, and even we have these HIV viruses. And then complex symmetry, we have pox virus. Pox virus is the best example for complex symmetry. So the picture shows pox viruses. And based on those, you can classify viruses into different categories. So bacteriophage viruses which attack bacteria is called as bacteriophage. Then cyanophage viruses which attack eat cyanobacteria is called as cyanophage. Mycophage viruses which attack fungi is called mycophage, and phycophage viruses which attack algae is called phycophage. And polyphage viruses which attack only E. coli cells are considered to be polyphage. Phage means to eat, so viruses even kill some other microbes. Based on Baltimore classification, it's a very important classification discovered by David Baltimore, it's American bacteriologist, American 1971. It places viruses into 7 systems based on their nucleic acid. Then standardness, whether it is a single stranded DNA or double stranded DNA, whether it is single stranded RNA or double stranded RNA, and sense plus or minus, and method of replication. And these groups are designated by Roman number. So this is the classification of Baltimore system. Class 1 double stranded DNA, class 2 single stranded DNA, class 3 double stranded RNA, class 4 single stranded RNA. Then we have class 5 some single stranded RNA, then class 6 single stranded RNA, RT, reverse transcriptase, and double stranded DNA, RT viruses. So there is 7 classes of Baltimore system of classification. Class 1 is a double stranded DNA virus, the production of mRNA and genome, application of asset from host genome. So the important example is pox virus. And class 2 single stranded DNA viruses, they form double stranded DNA intermediate during replication, and this intermediate is used during transcription as RNA polymerase requires double stranded DNA as the template. Then class 3 double stranded RNA virus, and class 5 aggregation single stranded RNA. So both are same. mRNA must be synthesis, but cells do not have RNA polymerase, so they enter the cell along with genomic RNA. Hence, in this case, complementary plus strand is synthesized by RNA-dependent RNA polymerase and used as mRNA. Plus strand is used to make morphological strands. And class 4 constitution single strand RNA, while genome serves directly as mRNA. mRNA codes virus specific and RNA-dependent RNA polymerase. This polymerase will make complementary amino strands of RNA and then use as a template to make more plus strands. Classic single stranded RNA genome that replicates the DNA intermediate. This RNA virus requires reverse transcriptase to copy the information found in RNA to DNA. Best example you can tell HIV virus. In class 7 double stranded DNA genome that replicates with RNA intermediate. mRNA is produced as in class and in the reverse transcriptase process. The example you can tell hepatitis B viruses. So with this I'll conclude this topic. So these are the very important classification of virus. Thank you.